What's going to happen is a particle of mass 20 kilograms is held on a smooth plane, which is smooth plane means right away, what would that mean? No friction, okay? So whichever way it moves, it's going to avoid the friction, okay? Which is inclined at an angle A to the horizontal, where tan A is 4/3. A particle is connected to another particle of mass 15 kilograms, so it means of a light inaccessible string passing over a smooth pulley at the top of the plane. Find the common acceleration of the two particles corrected 2 decimal places. Does the 15 kilogram mass rise or fall? Now, if it was straight down and you had 20 kilograms on the left and 15 kilograms on the right, it's a no-brainer that the 15 kilograms goes up and the 20 kilograms goes down. However, because the 20 kilograms is being partially supported by the plane, it's not a dead cert that the 15 kilograms goes up and the 20 kilograms goes down. So what you just make a call and you work a consistent system with that call. And if you're wrong, your acceleration will turn out to be negative, hence correcting its direction. Okay, so it's no big deal. So what we're going to do is I'm going to call this going downwards here, acceleration A. They're both linked by one string only, and there's only one part of the string linked per particle, so the accelerations have to be the same. Okay, so what we're going to do is we're going to zone in on each one individually, and when we zone in on them, we're going to see what forces are acting up on each one. So this is going to be the 20 kilogram particle. So the 20 kilogram particle has what going on with it? It has tension pulling it up, and then what way is its weight acting? Can you tell me its weight? Its weight would be acting in this direction here, straight down. So what is the weight of a 20 kilogram particle? 20g, or 20 times 9.8. You're good. We also know that tan A, we can just do this in the corner, tan A is 4/3. Hypotenuse is going to be 5, so that means that cos A is opposite over adjacent 3/5, and sin A is 4/5. I'm trusting you guys to be able to take care of that this way. Now, we have two components, okay, and this is also your angle A. Same thing as projectiles, isn't it? Where you draw your weight going straight down, and it's always angle A. Everybody happy enough with that? Now, what does that make this component here? 20g cos A, otherwise known as 20 multiplied by 3/5. 12g. The other one? 20g sin A, otherwise known as 16g. So you have 16g. If you're lying on the side of a cliff, especially if it's smooth, alright, you're going to be experiencing two things. You're going to be experiencing a force on your back. That means that your back is touching the plane. The second experience is that you're going to be sliding down the hill. Everybody happy enough with that? So when you're sliding down the slide when you're young, in the playground or whatever, you notice two things. A, you notice your back is always in contact with the slides. That explains this green force here. The green force is what's shoving your back into the slide. You also notice a purple force that drives you down sends you down the slide. They're the two forces of weight broken up into two components. Okay, so that's that diagram done there, right? So what we'll do next is I'll just do the formula for the 20 kilogram particle while I'm here. Now we've always used ma equals f, okay? What way did we say the acceleration is going on this one? Anybody? We said that it's getting dragged up while the 15 kilograms is being taken down. So what can we say next then? What's ma for the 20 kilogram particle? 20 times a. What force drags it up the hill? T. So 20a going up the hill equals t going up the hill. Is it minus anything? 16g. 16g is causing you to slide down the hill. And that there is your first equation. Okay. Next equation we're going to do is the next equation after this we're going to do the 15 kilogram particle. Okay, so 15 kilogram particle is going to be down here. Now it has a tension going up, 15G going downwards, so it's ma equals F. Its mass of acceleration is 15a. Its F is going downwards, so it's 15G going downwards minus T going upwards. Okay, so now we have our two equations. So you have 20a equals T minus 16G, and we have 15a equals 15G minus T. Yeah. So what happens next, guys? 35a is equal to T's cancel minus G. What does that mean about my assumption? It means that the A was going upwards and this one was going downwards. It's not a big deal if you get it wrong because it's going to fix itself anyway. So then what you get next? A equals minus G over 35 ms to the minus 2. Okay, second question, does the mkg mass rise or fall? Anybody? I said it's falling, but because it's negative, it means it's actually going in the opposite direction, which means it's rising. It doesn't rise, it doesn't fall, it rises. The diagram shows a 6 kilogram particle connected to a 12 kilogram particle connected by the means of a light inextensible string passing over a smooth pulley. The particles are both on slopes, rough slopes. The angle of the slope in both cases is 4/3. We'll just call that angle A. So that's A here, A here. Now in the last question we only had one force. Remember in the last question where we only had one force going against the motion? Friction is now going to be additional force that's going against the motion. Okay. Next thing is we're going to work out what cos A and sin A are. So opposite is 4, adjacent is 3, hypotenuse is 5. That means that cos A is 3/5, and sin A is 4/5. Everybody happy enough with that? 3/5 and 4/5 respectively. Okay, now once we're done with that, the coefficient of friction in both cases is 6 to find the common acceleration of the particles. Okay, I'm going to draw both diagrams individually. So we'll start with the 6 kilogram. There's there. Okay, 6 kilogram. It's very easy to predict the acceleration this time around, isn't it? That one's going to fall. That one's going to rise. That's very easy to know. Okay. Second thing is 6 G's has to go directly down. All 6 G of them. And then we have our gravity triangle. So what can you tell me about this component here? Anybody? 6G cos A, otherwise known as 18/5G. So just leave it as 18/5. Okay, and the other one? 6G sin A, otherwise known as 24/5G. Okay. This one's going rising with acceleration. What's dragging it up the hill? Tension's dragging it up the hill. So you have T. Bringing it up the hill. Okay. Now, what goes down? Anybody else? Friction, okay? So friction equals mu r. Now, here's the thing. What's the r value? R is is what you experience on your back when you're sliding down a slide. You don't experience your full weight as if you're lying on flat ground. You experience a fraction of your weight. The fraction of your weight is directly in balance with the other part going directly downwards. So what's the R value, anybody? R value is 18 over 5g. Now, we got to get 1/6 of that. What's 1/6 of 18 over 5g? Anybody? 3 over 5g. Okay, so the friction is going to be 3 over 5g. We'll construct its equation while we're here. Okay, so acceleration going up the hill. So ma equals f. Okay, so what's ma going to turn into? Can anybody tell me ma? 6a. What force leads up the hill? Tension going directly up. Anything working against it? 24 over 5g, your weight acting against it, and followed by friction also acting against it. And then this full formula becomes 6a. Yep. So this is going to be T minus 27 over 5g. Just a quick note about the R acting directly up here. Because the block and the slope, they're always directly in contact with each other. The block isn't lifting off the slope, nor is the block sinking into the slope. Okay, this means that they're in perfect balance. So your R value going directly up equals the component of weight going directly down. So they're in balance. And these questions, the R value is only pretty much used to find the friction. Okay, so that's one equation there. Now we're going to do the second one, which is our 12g particle going this direction here. Okay, so we have our our 12 all our weight acting directly downwards. Then we resolve it horizontally and perpendicularly. Okay, so that there is A. Everybody happy with that? And then what does that make? It's going to be 12 G's acting directly downwards. So what does that make this side here? This one here? Nobody? 12G cos A, thank you. 12G cos A, otherwise known as 36G over 5. Multiply 12 by 3 over 5. You get 36G over 5. And the other one being 12G sin A, otherwise known as, we're going to have to multiply by 4 this time, aren't we? 48G over 5. Okay, going down, going up. Now, like the last question, it has a reaction force supporting it from the slope of the plane. We'll call it S this time. S is the same thing as R, except it's just a different letter needs to be used because it's a different particle, okay? So S equals 36G over 5. Reason being is they're static in this direction. It's also known as statics. Basically, what goes up equals what goes down. There's no net acceleration in that direction, okay? Next thing after that is we're going to use the F equals ma, or ma equals F. That's what I'm doing recently. What direction is the acceleration? Acceleration is going down. Tension is going up. Anything else other than tension working its way against you? Friction always opposes motion, so we have a frictional force also acting here. Now, frictional force is going to be mu s, which is 1/6 of 36G over 5, which is going to be 6G over 5. So there's our 6G over 5 acting in the opposite direction to it. Okay, and our weight acting. Our weight is what's sending us down the hill this time, isn't it? So, F equals ma. Let's begin. What is going to be the m value? M value? 12a. What force sends us in the same direction as the acceleration? Always start off with them. What sends us in the same direction as the acceleration? 48g over 5. Components causing us to go down the hill. What is acting directly against that? T going upwards, and 6g over 5 friction. Okay. Sometimes known as a WTF system. Weight, tension, and friction. It's a good way of remembering it. Okay. Other people use the acronym for other reasons on these questions, but weight, tension, friction. Okay. Now, what we have next is going to combine the 48g with the 6g to create a 42g over 5 minus t. Now, what we've noticed now is that both equations have actually turned out reasonably small from big beginnings. They're actually both quite manageable now. So, there they are directly underneath each other. Now, next is we can add them directly down. What happens? 18a equals, t's cancel, 42 minus 27 is it 15? Yeah, I've got to put down 25. 15g over 5. Anybody? 3g. 3g divided by 18. 3 over 18g, also known as 1/6 of g. I think that's right anyway. So does it want me to find the tension as well, or just the acceleration? Tension as well. Brilliant. Okay. So pick one of the formulas to work with. I'll just pick the one that's closest to me because I'm lazy like that. T equals 6a, bring over to 27 over 5g. T is equal to 6 times 1/6g plus 27 over 5g. It's going to equal g plus 27 over 5g, which is going to give me 32 over 5g. Tension's measured in newtons as well, so it's technically newtons as well. We all good with that? Yeah. What we get next is a diagram. Shows two particles of masses 12 kilograms and 13 kilograms connected by means of a light inextensible string passing over a smooth pulley. The angles with the horizontal are given by tan A equals 4 over 3 and tan B equals 5 over 12. Find the acceleration of the particles and the tension in the string. If both surfaces are smooth is part 1. Part 2, if both surfaces are rough, having a coefficient of 1/4 with both particles. Got to draw them separately to start off. Which one do you want? I reckon the 20 kilogram is on a steeper slope to begin with. See the way the 20 kilogram is much steeper than the 13 kilogram? That means that the 20 kilogram will more than likely fall while the 13 kilogram goes up. Has to happen that way, more than likely. Now, there is a case where you could be wrong, where a 20 kilogram particle is on such a shallow slope, as in something like this, compared to the 13 kilogram particle that might be going straight down. In cases like that, it's not always obvious. So in a case like that, a smaller particle can pull a bigger particle. Okay. Now, so let's start off with the 20 kilogram particle. Okay. So might just actually have an idea for this, make my life a bit easier. Just yeah, no, you can't exactly do this in a test, but there we go. Just being lazy about it. Okay, we'll go down. Now there we go. There is the 20 kilogram particle. make it a bit more like that. Okay, so we're noticing that tension going upwards. Currently no friction. Okay, currently no friction because it says it's smooth. What you're then going to do is you're then going to find out what cos A and sin A are. Anybody have any idea what cos A and sin A are, given that tan A is 4/3? Sin A being 4/5, cos A being 3/5. Okay, you're going to draw parallel and perpendicular to this, so it goes your weight goes straight down, and then we need to draw something that's perpendicular right there, and that is parallel. So that's our weight triangle, okay, or gravity triangle, so to speak. This is angle A. Now this is 20G acting downwards. What can you say about this part here? 20G sin A, and 20G sin A will also be known as 12G. And then the other one is 20G cos A, otherwise known as 20G, not 12G. 20G cos A, anybody? Multiply by 3/5 and you get 12G in that direction. Wait a minute. Oh, sorry, the first one's 16, is it? And the other one's 12, sorry. That's 16G going this direction, and that's 12G going this direction here, okay? So we're just going to work on the formula to the left here. So MA equals F. A going diagonally down this way, so we want our force to follow suit. So 20 times A going in this really steep incline is equal to what, guys? Anybody? 16G minus T. Very handy. Okay, one equation done, next one up. Okay, once again, I'll just take a quick picture of this side of this base, what you're doing anyway. Okay, there you go. And then I'll bring that down with me. We'll go all the way down here. So this is drawing your particles on separate diagrams. Okay, sometimes you're asked to do it in tests. Now, what do you think about this, guys? What's tan B? I think it's 5/12, was it? Tan B is 5/12. That is a 5, 12, 13 triangle. So sin B is going to be, that's using Pythagoras' theorem, obviously 5/13. And cos B being 12/13. Okay, so through this, draw one going perpendicular. It can be as long as you want, by the way, it doesn't have to fit in. And then you can do one that goes parallel to your plane, like so, and then join them together. And now you have your diagram here. This is going to be angle B. That's whoa, one thing I do have to make sure I do, so just give me 1 second there. Have to make sure that your weight goes directly down. So that was almost wrong. There you go, a bit better now. Okay, so that's B. That's 13G aiming directly down. That's 13G cos B in this direction here. Also known as 12G, because you multiply it by 12/13. So that will be also known as 12G. And then the other one is going to be 13G sin B, also known for being 5G, because you multiply by 13 by 5/13. So you get 5G. Now you're going to make your equation. So any idea how to make the equation here? Which direction are we going? Going upwards, diagonal left up, diagonal left up. And then MA is going to be 13A equals F, which is getting pulled up by T, isn't it? So T going that direction minus your 5G going in this direction here. You got your second equation made quite easily. Okay, So what's the 20A equals 16G minus T. 20A equals 16G minus T. And the other one is 13A equals T minus 5G. Add them together. 33A equals, what is it going to be? 11G. A equals 1 over 3G. Are we just asked for acceleration, or are we also asked for tension? And the tension. Well, yeah, and the tension. Okay, so we find the tension now. So tension is equal to, I'll just move this over to your side. So tension equals 13A plus 5G. Tension equals 13 times 1/3 G plus 5G. 13 over 3 plus 5. 28 over 3G, isn't it? 5G is the same as 15 over 3G. 15 plus 13, 28 over 5G. You can probably just put it into your calculator. Yeah, 28 over 3G. So there you go, guys, for the mortals among us. Alright, so 28G over 3. Tension measured in newtons, okay? Now, great thing about the next type of question is I have half the work already done for it. I'm just going to modify. Okay, so I'm just going to get rid of all these workings that I did in the last question, if possible. And then what I'm going to do next is I'm going to go back up and we're just going to modify what we had before. Okay, so this was the original. So it now says that if both surfaces are rough, having a coefficient of friction of 1/4. So what I've got to add in is my friction. I'm just going to work with a green pen here just to add in the extras. Got to add in my frictional force. Now, if there's a force acting perpendicular to the plane, what's that? R. R equals anybody? 12G. Remember something, when you're on a slide, the steeper the slide, the less your back experiences weight. So you can be on a really shallow slide, your back will experience most of your body weight. When you're on a really steep slide, maybe at a water park or something like that, you'll notice that your back feels very little weight. That's because the components are changing, okay? So you're going faster down the slide, but you feel less impact on your back, okay? That's how the steepness of angle affects your experience, okay? So R is 12G here. This means that friction is equal to what, guys? Let's say 1/4, was it? The mu value? Mu value of 1/4, just always double check. There it is, there. So 1/4 of 12G. Anybody? 3G. Okay, so 3G. We'll add this 3G in at the back because it's always working against your motion. So 20A is now going to equal 13G minus T. Is that right? Now we're assuming that friction is going to slow down the acceleration, isn't it? So it'll be a slower acceleration than last time. So let's see if that's the case. What about here, guys? Friction once again at the back of it all. What's our S value this time? S value in exact opposite to the weight. S value is 12G. Your friction is going to be mu S, which is 1/4 of 12G, which is, somebody told me 3G. Okay, your friction's acting in the opposite direction, so you're going to have your minus 3G here. Then you're going to have 13A equals T minus 8G. So T minus 8G. Next thing we're going to do after that, put both equations together. Bring it down. There you go there. Add them directly downwards. We get 33A. That's the same as last time, isn't it? Sorry? If you're wondering where we got the S value of 12G from, if you circle this region in here, you're talking about a force that, whatever force goes directly down has to be balanced by a force going directly up. So you can see that the 12G is acting directly down, while the S value is acting directly up, so they're in balance with each other. So that's where we get your the plane is supporting you by not letting you sink into the plane in that direction. So that's why S equals 12G. Okay. Then the friction value is this reaction force multiplied by mu, which will give you 3G acting to the so 3G, which is the friction which is acting against your motion. Okay. Then you're going to get a 13A equals T minus 8G. Add them together. 33A equals 5G. A equals 5 over 33G. In the last question, guys, that was, anybody? That was 11 over 33G. So what effect has the friction had? It's caused the acceleration to slow, because friction is slowing, is opposing the motion in every direction. Okay, so that's caused that to happen. Right now, just make sure I'm right there. Yeah, I am right. Now the next one I just want to examine is the effect on tension. Do you think tension will have an increased effect on tension or a decreased effect on tension? Let's find out. The tension answer of the first question was 28 over 3. 28 over 3 being a value of 9 1/3. Okay, let's see what the tension value is in this question. Okay, so T equals 13A plus 8G using this equation here. T equals 13 times 5 over 33 G plus 8. Now what's we go for 13 times 5, so 65, yeah, over 33 plus 8. I think we can tell 9.96, otherwise known as 329 over 30. Yeah. Just 1 second. I think there's just a typo here. Yeah, it's a typo. 33 acceleration. Yeah, it's a typo. Okay, so it's 329 over 33. So in this particular question, the result of having friction in your slopes has resulted in a slightly greater tension than before. The old tension was 9 1/3. The new tension is 9.96 G. So there's a small increase in your tension. Okay.